Okay, now let's start it. This is Physical Science 201, Chapter 1. Now, we already have a Zoom session going on for the last week. This week, I start to record what we already covered in the lecture at the Zoom meeting, because there are students absent and or registered late. For whatever the reason, we are able to help them to have a YouTube video clips for each class, which I'm going to split into two small clips, 30 minutes each. And I will give you the channel number or channel name, and then keywords you can type in, and it's under the public domain. You're able to watch my video for the contents. Alright, so we probably have to repeat a lot of things because for those did not show up the first week. Now we already have used my notes, because I mentioned that we do not use the textbook, too expensive, $200-some, $240, and we only cover 1/3 or less of the chapters. But this class, Physical Science, is composed of two main subjects, physics and chemistry. Of course, both are science, were closely related to the basic mathematics. Now, I already talked about in the past week, and then you guys are non-science major taking this science course, so the content part for this course was limited to very lower level, not going too far. However, we have to involve lots of numbers, which is the math part, right? The math part. And we also discussed the difference between math and the science. The common ground, they both have to deal with the numerical value, numerical numbers. But science goes one step further. It will involve lots of scientific units. Now that is going to be the topic for this chapter. We call the scientific units, which we call scientific base units, total number 7 of them, and their conversions, plus the measurements and the error data treatment. I don't have space to put all the long title down there, but I think you already got my notes. I will send out tonight, and when you watch my video, and then this will be a note made by me, and I already introduced last week. It's going to be a flow chart with 3 columns, right, line by line, and the line by line matching up from left to right, and the column is classified as the concepts and the problems, and the first column on the left, and the middle column will be the equations, definitions, or explanations, right, the solutions. And then the third column takes a little more space because I want to put more example in there. Right? That's the notes we shared at the Zoom meeting with a share screen. Right? If you remember that. And we already covered first 2 pages. So we are going to go same order and then go again. And then everybody, if you are able to get your notes download or print out in front of you, or you have another computer and then have that notes open, and then we are able to use that notes at the same time listen to my explanation in the class. I'm going to put very concise short notes instead of spend time on writing on the board, but we're going to do a lot of the writing because we're going to discuss a lot of conversions, how to do that, right? And that's the time for using YouTube, so you are able to see the video, all right? How to do the problems. All right, that's what we're going to do. Now, when we talk about the scientific base unit, as I said, in this country, right, it's very special because we do not use the international units in the routine life. We use our own system called English system, which is an older system. The inventor, the British, already abandoned it, right? But we're still using it. Now, we're going to have to face the dilemma how to convert English system units into international metric system, but same time it may not reach the final destination for the units the problem asks for, so you have to do the conversion within the metric system as well, right? So that is a dilemma we have to face. We have to go one more step than the rest of other countries in the world, because they don't need to deal with English system, because science do not use the units in English system, right? So, but we do. So we basically have to deal with these two things, right? So the physical, no, it's not physical, scientific unit, right? Scientific units, wherever fit, right? Scientific base units, a total 7, right? 7 of them. All right, you already see it on the notes, right? And then because we have to deal with two systems, so in my notes, and I listed side by side. I made a small table. So we go by those scientific base units, some of them. Then in my notes, I put links first. So we're gonna do the same order, right? So the first one, if you put one die, we say links. Right? Links. And we have definition, right? Links is links is one-dimensional, right? Entity, right? And in the three-dimensional space, so one entity, one-dimensional, and then that is take up space, right? Take the space, and that is the definition. One-dimensional entity for a distance. So we don't want. So that's the 1D, one dimension, 1D, right? 1D entity, right? For distance, right? In space. All right. 1D. That pen was dried out. All right. So. Alright, and then, but on this side I have to list the two different systems, right? So the first one on my notes, right, you have a metric, right? It's called SI system. Now we already said SI stands for Système International. That's a French. I do not pronounce very well, but you know what I'm talking about. And then on the other side, the English, right? On the other side, the English. Right, English system, and I also mentioned the English system is kind of chaotic, right? Do you remember I mentioned that it's a chaotic? This marker dried also. All right, so you have these two systems now for the links, right? Because why chaotic? We already mentioned because English system, the converging factors are random. Right, so messy. Like a 1 yard equals 3 feet, but 1 foot is not 3 inches, but 12, right? And 1 mile is not even 3 yards. 1 mile is 5280. No, it's not 3 feet. And 1 mile is I think 1500 some. No, it's not 52. Yes, 1700 some yards per mile, but 5280. Feet per mile. So those converging factors are so random, and you have to remember so many. That's not convenient. And then metric is, right? Metric's 10, 10, 10, 10, always 10. Either 10 times bigger or 10 times smaller, or 1,000 times bigger or 1,000 times smaller. Right? So, but links in English system, right? We have all kind of mile, right? Mile. So you have mile. And shorthand is MI, right? And then yard, and the shorthand is YD, and you have inch, right? Inch, and shorthand is IN or double apostrophe, quote unquote, right? Or the feet, right? Or the foot, and then FT. Now they all have different kind of different value of conversion factors. But here in metrics it's just simple, meter, right? Meter. So meter is M, right? M is going to be printed. I'll put 3 dots down there so make sure you understand this is not italic. Because if you go to italic, that M is no longer the symbol for meter. It's going to be the symbol for prefix milli. All right, milli. All right. So if you have a millimeter, then it will be 1 in front of the italic. The second one should be printed. All right. So but I don't think every textbook has gone that far in details. I do. All right. So that's what's the standard for the meter? I already talked about, right? The standard for the meter is what? 1 out of a 10 millionth the distance from North Pole to equator, right? So we already talked about. So what is that? So it's a 1 out of 10 million, right? From what? From North Pole, right, to equator. Right? That is the standard for meter. So I already said in class, I said from North Pole to equator, not South Pole to equator, because the Earth is not perfectly symmetric. So the distance from North Pole, where it's one spot, that's exactly where the location we call North Pole, on top of the Earth or on top of the map, right? And then the South Pole to the equator in the middle of the Earth. The Earth is flat, slightly flat, right? 26 miles, a little wider across the equator than North Pole to South Pole, right? Because the Earth was spinning and then self-spinning, so the mass tend to be thrown away from the center on the side away around the equator, so it's a little bit wider. Okay, and then, we know the difference from South Pole to equator. We picked up one of the two. We picked up North Pole to equator. That's another reason I think is because this is historically a long time ago, and then the humankind did not even realize we have what? We have a southern hemisphere, right? It's called what? Down under, right? It's called down under. You go to Outback Steakhouse. Now it's closed because of the virus, right? But it's called down under. Down under means you go to Australia, go to New Zealand, right? That part of Earth, that part of Earth have a human being down there, but we don't visit each other until recently, right? So we know, but only probably hundreds of years, right? So we didn't even know. The scientific standard was set up then north. Most people living on the northern hemisphere side, so we picked the North Pole to equator. Probably that's another reason I would say that. All right, so this is, but in the mile, right? In the mile is 1 mile equal how many feet? 5,280 feet, right? And the 1 foot equals 12 inch, and the 1 yard equals 3 feet. So that's very, very messy. But here the convenience is a meter. It's just a meter as a base. If you 10 times smaller than a meter, we call it decimeter, which is 0.1 meter. If you 1 centimeter, which is 0.01 right meter, right? So you have we can have an example right here, right? We have examples, analogies according to my table, right? It's called an example given, analogy given, right? And special notes, right? Special notes. No, I'll still have time. I'll still have space. I think my board, this camera, can only cover up to here. So special notes, right? Right, it's going to be starist, right? Special notes. So on this side, that's my notes, right? That's the style of my notes. So example, and so one centimeter. Now this is italic. Centimeter, right? Is going to be equal to 0.01 meter because the 100th, or centi, right? And then if it's 1 millimeter, right, 1 millimeter is going to be what? 0. Decimal point bigger, 0.01 meter, right? Because 1,000 th, right? But this is what? 1 million th. 10 million TH, 1 over 10 millions, right? So it's already on my notes. I was just repeating and explain to you as we are in face-to-face in the classroom. Of course we're not, right? So that's one. And then second, right, major scientific base unit is the mass, right? The mass. Now since we already started the table right here, metric system, so we keep on going, follow chart going down, right? On your notes, the notes I will email you, you will see this is same thing, all right? So if I show you, and then it's gonna be, it's gonna be the table, right? Right here, right? If you can see from the camera. So here's the lengths and the mass and temperature and time. We already covered. I'm repeating here. We already covered, but we have to take care of the people, the student not show up, right? So we go down the table, going down. On the left, the metric. On the right, the English. All right. On the right hand side is the examples. All right. So that's the table. That's the notes you will receive. So the mass, right? The mass. Right? What's the mass? Defined as what? Anything tangible, right? Anything tangible. All right? And then they possess certain mass, and anything tangible, and possessed by those tangible items which are occupy or take up some space. That's so the mass will be possessed by anything. Right? Anything tangible, taking up space, taking up 3D space. All right. If it's not tangible, your dream, your nightmare, and then I said in my class, I think either section, all right. Monday, Wednesday, Friday, or Tuesday, Thursday, right? Tuesday, Thursday we meet 1.5 hour. Others will be 3 hour, split into 3 sections. Monday, Wednesday, Friday. But we already covered. And then I said, well, I had a dream. My sister did not get my consent, and then she helped me bought a set of a brand new washing machine, dry, and then delivered to my door, and then unloaded on my front yard, and then back off was the truck and then the dolly, and almost hit my house. That was my dream. And that doesn't seem to have any tangible item, but in my dream I do see some image, but then I wake up, oh, that's a dream. You know, is there any real machine in front of my door? No. Alright, you cannot touch it, nothing down there. But it does not take up any volume, so that is not, the item has any mass, right? And we also mentioned this mass. We talk about mass and then the gravity and the weight difference. So we talk about it. In the metric system, it's also very, very simple. One base unit. It's got a kilogram, right? On my notes, I have K, supposed to be italic type because the prefix. Kilo, right? Kilo. You know what a kilo is, right? Right? And the people selling those kilos on the street, right? All right, a kilo what? Kilogram, right? Kilogram, not gram. Now this I put in parentheses say not. It is not gram. It just happened. It just happened in the past when the convention was set. Somehow we use a kilogram instead of a gram. It seems to be gram is 1 unit, 1 gram, but kilo is 1,000, right? But somehow in the past, 200-some years ago, maybe 300 years ago, and then the scientists, right, had a convention, which is called a Congress for International Standard, right, material and weight and material something, you know, in Paris, and they discussed and they put kilogram as a standard for mass in metric system, in international SI system, right, you know, but not gram. So you have only 1 out of 7. That is only unit bear a prefix. Now, pay attention to that. I tried to get all these most important things to let you know and to pay attention to, right? 10 more minutes. All right. So but then that's a kilogram for metric system. However, on the other side, the English system is so chaotic. I forgot to conclude parentheses. Right. What chaotic is? It has pounds, right? And it has ounce, right? And in the ounce part, I mentioned the 4 of them. Right? 4 of them. But one is not. Quote unquote 4, but only 3 of the ounce in English system. Right? Regular ounce, troy ounce, and another one is MED, something for medication. Right? The ounce, right? But ounce is too big. Sometimes too much medication will kills people, kill patients, right? So ounce, they use that in this design of the fluid ounce. The fluid ounce, FL period, OZ period, that use the ounce, but it's not representing the same thing as the rest of the 3. For mass, it is designed for volume. We already talked about that. Right? So we have to pay attention, right? So in the example, right, 1 fluid ounce, actually, right, 1 fluid ounce, it's the volume representing what is the liquid. Fluid means liquid, right? Liquid. It represents 29.6 milliliter of liquid of any kind. So if you use 29.6 and you time I think times 16 or something, and you end up with 500 milliliter. Now you have those bottled water, right? You buy a bottled water, it says ½ liter bottled water. You go by Walmart, right? Great value, right? And any kind of bottle, and I don't have here right here, but that says it says 16 ounce, right? And then on the side it says in the parentheses 500 ml. So 16 ounce. 16 fluid ounce, that's exactly the 500 milliliters. So you use this time, if you times 16, right? 16 milliliter, wait a minute, 16 fluid, yeah, that is 16 ounce, right? 16 fluid ounce, right? If you times 16, and you get what? You get that's a per fluid ounce right here. Right, per fluid ounce right here, and you times 16, that get 16 fluid ounce, right? You cancel fluid ounce, and you end up with exactly 500 milliliters. So that's a bottle of water, right? That's a bottle of water, right? All right. So, but then you have pounds, right? Pounds is now we're going to give you a conversion factor, right? Pounds is the English system for mass, but we know the pounds doesn't fit into a foot. Foot is 12 each. Pound, is that 12 ounce for regular ounce? No, it's a 16, right? Everybody knows that. So you have ounce, 16 ounce. So, and then you not only have that, and you have what? You have in my notes, you say, when you see the mass, it's a bushel. There's something called a bushel. Bushel. We already mentioned that. Bushel is a unit for mass, all right? But actually, it is just like a fluid ounce. It's not measuring the mass. It's measuring the volume. The volume of grain, all right, the bushel. But if you go to commodity market, since you want to buy soybean, rice, wheat. Now the wheat spells W-H-E-A-T. It doesn't spell W-E-E-D-S, okay? And if you want to buy some wheat, right? And they're going to use that bushel. The bushel looks like, I'm going to use this space, draw a picture, and I'm going to erase it up. It looks like some kind of fiber from the plant, either the wheat or reel or something. And then it's going to be in this kind of shape. All right, they all, right, woven into a basket type thing, right? A basket type thing, and then you pour your grain into it. You pour your grain into it, and then use a ruler. Use a ruler. Flat to the top. Wipe off everything extra, and that's got 1 bushel of something. But you know that if that's the case, if I put flour in there, or just put, let's say, rice in there, 1 bushel rice, say weigh 20 pounds. How about I put 1 bushel, I fill up with 1 bushel with ping pong ball, right? We already mentioned that. Ping pong is hollow, this big, and then it won't take too many, probably less than the 200 ping pong ball going there. It's already filled up to the top. And then you use the ruler to wipe off, and then the top, and then that ping pong ball, that 1 bushel ping pong ball probably weighs only about half kilo, right? It's a 1 pound, 1 pound or 2 pounds. But if it's rice or if it's wheat, it's going to be 15, 20 pounds. So that's not mass, but it's one of the mass units used in commodity market, right? Commodity market. So that is terrible in English system, right? But then the troy ounce we talk about also. We talk about you have 2 bushel is a 1, and then the pound ounce, right? Here's a kilogram, and then but in English system you have 1 ounce is a regular ounce is going to be 28.35 gram, right? But if it's 1 troy ounce, which is I mentioned in my notes also said, but I don't think I put down there. It says precious metal, but I already mentioned in my class. This is repeating. This is repeating. That's double effort, all right, for you, whoever need to review. All right, you're going to come to watch the video on YouTube. All right, on YouTube. All right, and then your review. I'll repeat for you, and for each hour split into 2 30 minutes video clips, and the post on YouTube under the public domain. You can always type in the keywords like I think JSU Peter Chang physical science and Dr. Learn from you and chemistry or physical science. I will give you the title or the channel. You're getting there to watch it. So the troy ounce is for what? Precious metal. What is precious metal? We already mentioned. Troy ounce is for gold, for silver, for platinum, all right, or white gold. White gold is a gold and silver or some other metal alloy. And the contents of the gold part is very low. It's probably less than 50%. So it's cheap, right? But the color is white. It's not gold, yellow color. Right? It's not white. It looks like silver, but it's a little more expensive than the silver. But it's also considered a very precious metal because it's very expensive, fairly expensive. And there's other metals can be considered precious metal. One is tungsten, one is titanium, right? Titanium make the nozzle of the jet airplane, right? The very hot temperature, is resistant. Tungsten's highest one about 4,000 Fahrenheit or 4,000 Celsius temperature won't even soften it. So that's the very expensive metals. Indium, all right, very soft and very low temperature. It melts at 153 degrees Celsius, right? Those are expensive metals, and we use troy ounce. So what troy ounce in the international system, even ounce English system, is conversion is 31.1 gram per troy ounce. So these two different have a 2.75 gram per ounce between regular ounce and troy ounce. If you go by gold, they can cheat you with that value. If they think you don't know, then you should get this much, right? Each ounce. Get this much. What's a little scale, right? If you have a little scale, I do, those little scale for 100 gram. You verify how much they give you, right? So they cheat you, right? You're gonna find out, right? So that is the difference here. So the English system has so many different ounce and pound, and it's chaotic. And then between themselves is 16, right? And this is not even 16. This doesn't even go pounds. It only by ounces. Troy ounce only by ounces. Because I never heard of people saying gold by pound, right? You may buy metric tons. That's gold metric system. It's not the same thing, right? So that's mass. Then we have the third one, right? The third, right? Third is what? Third, on my notes, we talk about temperature. Right? We already covered this. The time's almost up. And in 30 seconds. Temperature, right? But in metric system, we consider this is the only metric system temperature scale called a Kelvin. A Kelvin, right, is a name of, I think it's an Australian or New Zealand scientist, or British, but anyway, not using science, right? It's only using science. only use Kelvin, right? But then in our country, we use Fahrenheit. We use Fahrenheit. And in the rest of the world, we use Celsius. Now, time's up. We're going to continue next section, say part 2, all right? Let's